It's time for pure performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always, I have with me my co-host, Andy Grabner. Andy Grabner, step on down. How are you doing it today, Andy?
Very good, Brian. Thank you so much, and I'm pretty sure you were a little bit surprised that I didn't mock you during your introduction. It's a running joke. It kind of almost traces back for many, many episodes now, right?
God, you're so good at that. Oh, keep going. It traces
back.
We're
interested to trace it back all the way to the beginning where this all started, kind of the root cause, the moment that ignited all this. And I don't know what else to say.
Yeah, well, I think you said enough. But and as our loyal listeners and for our guests, Andy always has a great way to tie in something from when he first speaks to the episode. So that's why I reacted the way I did. And speaking of our guests, Andy, would you like to?
Speaking of our guests, speaking about tracing, tracing, distributed traces and distributed tracing is the topic of today. And I want to be upfront and honest. We have 4 dyna tracers today on the call. So there might be some bias, but we try to keep this as educational and neutral as possible. With us today, Christoph Neumueller and Thomas Rothschaedl from our product engineering team. I want to start with Christoph. Christoph, thank you for being here. Could you quickly just say, who you are, how long with the company, what gets you excited?
Yeah. Hi, Andy. Hi, Brian. Thanks for introducing. Pleasure to be here. So I'm Christoph. I've been with Dynatrace for 13 years now. 2011, started as an engineer in the agent team, so data collection. And I'm now a product architect in the observability space in Dynatrace.
Perfect. Thank you so much. And then Thomas, how about you?
Hello, Andy. Hello, Brian. I'm now with the company since 10 years. I started originally in the pre-sales and moved over to product management. So now I'm a principal product manager caring about tracing and topics around distributed tracing in Dynatrace.
Very cool. And this just shows, I think, some of the big qualities that we have in our organization. Yep. We've all been here for a very long time. Brian, you started back when?
2011, same as Christoph.
2011, yeah. I started 2008, and I think this also shows we have collectively more than 40 years of experience in distributed traces and in observability. And I know that a lot of people are kind of entering this field new, thanks to all the work that has been done recently in the CNCF, in cloud native, especially around the projects Prometheus, OpenTelemetry, bringing traces, logs, metrics to the people that really need it in an easier way. But I think what I want to do today, I want to go a little bit back in history first to talk a little bit about the problems that we as vendors, and that's not just Dynatrace, right? I also want to mention the AppDynamics, the New Relics of the world, the Datadogs of the world. There's many out there that have built observability platforms over the years, trying to instrument on the fly without any code changes, and then facing and tackling the challenges of capturing a lot of this data in large amount at scale, storing it and analyzing it. And I think, Christoph, you said 2011. If you could maybe take us back a little bit in history, if you do a little bit of a history recap on your end, on how everything started, that would be good for me to know.
Now, for me, what I want to tell is a aha moment for me when I first, started working at Dynatrace, got my first introduction into the product, and as an engineer back then, first time I saw a trace in Dynatrace, a pure path, I was pretty blown away because it back then, 2011, it showed me the flow of the transaction through my system. It showed me when exceptions happened in my flow. It even back then showed me the logs associated within the trace.
Mm-hmm.
And a new feature back then was I think AppMon release 4.0, if you remember, Andy.
I do.
Was the first time we even put profiling into tracing. So we had some form of continuous profiling that would go into the trace, the auto sensors, if you remember, Andy.
Mm-hmm. Mm-hmm.
So first time I saw this, I was blown away by how cool this is, and I could now debug my stuff much, much better because I have all this inside.
And it's like, and thanks for bringing all this up. Right now, the industry has moved to provide these things, or is about to provide all of these things you just mentioned as a standard logs in the context of a trace, sampling and profiling information. And it's I know over the years we have figured out our ways to do this at scale, to analyze this at scale. I also remember all the challenges we had, because the first experience I had with one of our customers that turned this on, and then they had debug logs, and they had millions of debug logs in their transactions, and then we blew up all these distributed traces. These are all things that is a topic for also later in the discussion around what is the real data that we should capture, which data we should probably not capture, which data should be rather translated into a metric other than capturing everything in the raw format. But it's, as you said, these concepts have been around for a while, and we have solved a couple of challenges over the years. And we are also obviously very happy to use opportunities like today to talk about this, so that the broader community can also benefit from our knowledge that we've built up over the years.
And hey, before we get over to Thomas, I wanted to bring up, you talked about the CPU sampling. So the fun part is that I was a customer for about 1.5 years or 2 years before. So I think I was on AppMon 3.5 was my first one, right? And the fantastic piece, and it's great to hear that OpenTelemetry is getting into this side now with the CPU sampling, is, I'm sure you remember, Andy, who had the sensor profiler where you can go in, it would show you all the different methods you might want to pick, and then you could make the mistake of saying, I want to select all of them, right? Yeah. Because we only, as any production level, trace application is going to do, there's only so many methods you could wrap around before you become a profiler and take the system down. And that CPU snapshot was just groundbreaking because it prevented you from over-instrumenting from doing this. So I just needed to give a shout out to that because, knowing that OpenTelemetry hadn't had that, and that it's either, I don't know what the status of it now, but the fact that it's coming, it shows, what a long way it's come. Anyway, though, we have a second guest, so why don't we go over to our next guest, Thomas. Then how do you say Thomas, or how do you say your name? Sorry,
Thomas. Yeah, Thomas.
Okay,
is fine. That's
all
perfect. Right. Yeah. It was quite interesting when I entered the company. This was 2014. It was the time when just one agent was born. So to do everything automatically, to just deploy one binary on your machine, and that takes care about everything. And this was the point when I was starting looking into Dynatrace. In the name, it was already there. But when we looked, we didn't show a trace outside of it. So we showed the things behind the trace. So we showed, information about the JVM, the services that have been there. And the first time that I then got aware about what the trace is in the backend was when I was looking at some developers there in the debug backend that visualizes the end-to-end trace, where all this information was coming from. And getting this automatically from users, from installing a binary, restarting your Tomcat, your JVM, distributed across systems, and also then to combine this with real user monitoring, so to see also browser stats, to see where the end users are located. This blew me away, and this was the time when I said, okay, I want to get deeper into that, how this works, because at this point of time, I had no idea how this technically can work to do all of this automatically.
Mm-hmm. It was an interesting transition, if I may, Andy, just briefly, from AppMon to Rothschaedl. AppMon gave you all the details from a single transaction and a trace, and it was awesome for debugging a single issue. Great. Rothschaedl went a step in a different direction, which was give you an analytics answer from many traces. So from millions of pure paths, we did analytics behind the scenes, baselining and root cause analysis already to give you an answer, but it did not emphasize the detail, the single trace a lot. So we went in this direction.
This was quite interesting to be there, to see then what was, from where this data was coming from where was it originating, and how the backend was then putting this together. And I think it took then 1.5 years till this trace perspective was even added to this product at this point of time. And as I was in pre-sales, I was fighting a lot. Hey, we need to expose this also in the UI here, because it was a hard time to show it comes from and how all these data points relate to each other.
And I think I just wanted to, for those people that are not familiar with the history, we started with Dynatrace, tracing in the name, and then we call it the second generation. We called it Rothschaedl. So we basically incubated a new observability platform, called it Rothschaedl, brought it to the market, and then eventually Rothschaedl became what Dynatrace has been for many, many years afterwards. And now we are on our third gen, current generation platform that is powered by Grail. I just wanted to highlight, because maybe not everybody is familiar with the word Rothschaedl. And just as you said, Christoph and Thomas, the interesting thing is we went from small scale, or let's say more the monolithic 3-tier maybe architecture, where the pure paths in Dynatrace, the individual paths, made sense to be analyzed by teams, then moving into more the cloud scale architectures, where we needed a different approach because it was no longer practical to look into millions of pure paths and find the needle in the haystack, and then kind of hiding the complexity behind the scenes and all this data, and first trying to give you really answers and root cause information before we brought the pure path back. Really an interesting story, I would say.
We could have a whole podcast on the history of Dynatrace and features, but we can't. I'm thinking of all these things. I'm like, nope, we're here to talk about traces. So, yeah.
Which now brings me though to, and a lot of time has passed, and we mentioned OpenTelemetry quite a bit, right? OpenTelemetry has also now been around for a couple of years. It was the merge of OpenTracing and OpenSensors. And what I would be interested in, I'm not sure who wants to tackle this first, maybe Christoph, how has OpenTelemetry also changed the way we think about distributed traces from a Dynatrace perspective? Because I know we have our agent. We've invested a lot of time with many engineers that work on the agent that provides automated instrumentation, all these features. How has OpenTelemetry changed the way we think about tracing?
Yes. So where do I start? It changed a lot in summary. And for me, the personal story began in 2018 when a colleague, Chris Spatzbauer, asked me to join some effort into standardizing distributed tracing. It was before OpenTelemetry, and it was rather about the context passing, which became W3C Trace Context. So he said there's a bunch of other companies who are interested in standardizing how we pass context between calls, so that the distributed trace can even be built up. We had such a technique for a long time built in PurePath, and now industry wanted to standardize. And I joined then these working groups that we did there, and said, how can we across vendors, even back then, make sure we pass context on so we can build up a distributed trace. It was about passing on trace ID and parent span ID and that kind of stuff. And within those groups, there was people from Google, from Microsoft, from New Relic, from Splunk. So at Dynamics, I hope I'm not forgetting anyone. Apologies if Instana was also present. So we held these meetings, and this became fruitful, right? Some years later, we finalized the standard. It's now very commonly used, also in OpenTelemetry. And why I'm mentioning this is also from that group, some people emerged into founding OpenTelemetry. Mm-hmm. Back then, 2018 was the situation also that there were competing standards. There was OpenTracing, who was a little provided APIs, not so much more. OpenCensus, which provided SDKs, which was capable of producing spans, also defined a protocol. And those were kind of competing because instrumentations didn't know how to program against OpenTracing, OpenCensus. So the merger was being, I think, announced 2019. And I was at the time involved with those people through Trace Context. That's why I know a little behind the scenes there as well. And the goal really behind OpenTelemetry was to standardize the data collection for observability to a degree where libraries know how to produce that observability data, like which spans and span data to produce, also metrics, events. It's all under this common umbrella. And then a standard protocol that can send the data to some backend, which the idea is to be exchangeable. And vendor agnostic, basically.
Mm-hmm. Yeah, that's basically the OTLP protocol, right?
That's the
OpenTelemetry line protocol.
Yes.
Yeah. Okay.
And I can't believe that was 2019 because it seems like it was just a couple of years ago, but we're talking about, 6 years now?
Yeah. It took time to stabilize. It's still stabilizing, but
but it still seems like it was yesterday, But I guess that's old age.
Yeah, and I think the trace context is also a quite important point because it was a first step to start with standardization to make sure that it's even possible to propagate the trace state across load balancers, across third-party systems, so that people started talking about this. This was at this point of time very often an issue what is this vendor-specific header? Why do you need it there? Why do I need to make my load balancer forwarding all this information there? This took a lot of time to convince people, and that all the vendors and agreed on a standard there to do that. This made things really easier, and this is, I think, key to even be able to have an end-to-end trace across such systems and also across cloud vendors and across all of this information. I think that was also an important point. Now it's convenient. Now everyone knows what is the trace context and how is it working, and it's built into the standards. But it was a good first step here. Yeah.
Because it solved one, as you mentioned, the big problem. We always had these situations where they said, hey, now show me the end-to-end trace. And then we said, well, it looks like we have broken traces, right? We have a little bit here and a little bit there. And then we try to figure out, well, what's in the middle? Oh, there's this load balancer, there's this proxy, and they're kicking out our header. And as we agreed on the standard, then this proxy load balancer could forward it and without any questions asked. Yeah. So we talked about OpenTelemetry. I think, Christoph, the two of us, we just recorded a session on distributed trace analytics on Grail, and you did a great job in the beginning of the session to explain kind of the autonomy. I think you called it the autonomy of a trace with spans. What is a span? What is a request? What is a trace? Could you quickly just do me a favor for the audience here to quickly explain that the core terminology, because I think that's very important.
All right, sure. So, the trace itself, it represents the whole transaction from beginning to end, right? Throughout your systems, multiple tiers, multiple hops. But that is built up from individual, pieces that is called spans. And those represent units of work within your distributed trace. That might be incoming HTTP. That might be outgoing HTTP. That might go an outgoing database call. It might also be an internal method execution somewhere. And those all have hierarchical relationships with each other. So each span has another span as a parent. So it builds up a tree, and there's a root. And it goes across tiers, right? Mm-hmm. Parent span can be a remote one from somewhere else. And each of those spans represents something different. That's why it also carries different information. A database call carries the database statement, the number of database rows that were affected by that database, if it failed or not, right? HTTP call obviously contains HTTP request method, HTTP headers. There is a range of what you can configure or what the instrumentation does. But that's kind of the data model of spans. is, depending on what operation it represents, carries different information.
And I think you also, in our recording, you referred to it. For you, a span is nothing else than a structured log, if you look at it from a technical perspective.
So this is an interesting point, right? You look at logging and what it logs, right? There's logging from standard frameworks that log if every HTTP call. Then, of course, there's also custom logs. Nowadays, it's very modern to see logs, to make them structured, so it's easier to parse and, do analytics on them. So you don't just write the text line, you write, all your elements of what you want to log in a JSON form or so. Now, if you think of spans, what are they? They are like also just logs that log the HTTP call or the database call or some important method execution at some point. The attributes on a span is nothing more than metadata of the, like in a structured log, the context and the metadata of that operation.
Mm-hmm.
So what's the difference? The span is a structured log with more context because it knows also the parent and what transaction it belongs to through the trace ID. So you can do even more powerful, analytics than on this.
Mm-hmm. So does this then mean, if I continue this thought, a span is nothing else than a structured log with certain semantic convention where you have certain minimum data, like the span ID, the trace ID, the parent ID, maybe a type, and then depending on what type it is, some additional metadata?
Exactly. Maybe let me go back a little bit to OpenTelemetry. So what you just said is, okay, there's a model behind spans, the data model, yes. Go a little back to OpenTelemetry. What they define is semantic conventions, which is basically a description of such data model.
Mm-hmm.
What is it that I can find on a database call? What is it that I can find on a HTTP call is defined in OpenTelemetry semantic conventions, which is very helpful because it allows someone who writes an instrumentation to know what to put on, someone who writes, more importantly, an analytics query on the data, what to expect, how to work with the data. In Dynatrace, we have introduced something similar to that, which is called semantic dictionary, but it's basically that. It is the description of that model that you can expect to find on traces. Mm-hmm. It's very closely aligned to OpenTelemetry conventions with some differences, but it basically describes how you can work with the data. Those structured logs, quote unquote, that are spans.
Mm-hmm. Thomas. Sorry, Brian, go ahead.
No, I was just going to comment on, thank you for explaining the difference between span and trace. I remember when OpenTelemetry, even OpenTrace and stuff were starting, and some brave people were venturing into the DIY component. When we would talk to them, all they would talk about is spans, right? And it took us on the pre-sale side some time to figure out, what are they talking about? We're talking about traces, it's the whole thing. They're like, but do you have all the spans from this layer? We're like, right? But because in those early phases, they didn't have necessarily the full trace, it was all about the spans. And I don't see that come up too much anymore, but I think it's definitely a very important component, right? The spans make up the trace. The trace is the full picture, which is very, very important, right? Yes, you might be a developer on a specific service or a specific area. You only care about that one piece, but you still have to have awareness of what's going on above and below you, which is what we've always been saying. Anyway, I just wanted to thank you for that, explaining that out.
And also watch the video. We will make, I think by the time this episode airs, the video with Christoph should also be out. Really some nice visuals and explaining all of this. Now to Thomas. Thomas, I got a question for you. So now as we have the data in our backend, for me, the question is, you are the PM, the product manager for the Distributed Traces app. I also know in the Distributed Traces app, you made a strategic decision, I guess, to also differentiate between requests and spans to support different types of analytics use case. Could you fill us in a little bit on what you typically see out there when people are now analyzing the traces, and maybe some additional thoughts that were put in so that we can actually analyze the vast amount of traces and spans.
Yeah, so I think that's also a very important point here, what you figured out. So one thing is that you typically want to find out if what failed in my systems. Did everything went well? Did everything succeeded? Or did something fail? And on which endpoint? So on which, what was the interface that was called here? Was it a specific HTTP request that reached a microservice? Was it a specific queue endpoint that was called here in that case? And all of that is typically happening on the request level, so where the information is coming in. And that is what is interesting here. So to understand, because not every technical error that happens further down on a small unit of work, what Christoph described, is leading to a logical or business error in the end, because developers made quite a lot of effort to build the code error prone and to deal with small technical errors, to do a retry out there. But I want typically to understand, okay, did it fail? I want to find it very quick, what failed, and then I want to go into the details to all of the small units of work, to all the spans, to understand what was really happening. Do we have specific error codes on it? Did any exceptions happen there? What have been the exception messages? And from there, I can then jump to related log files that hopefully also have some information about the trace or the span where they happened, that can give more information what really happened down there in the code and what can I do to prevent this in the future. So I think that's one of the important points, so to think about what is failing. The other point is to understand what was the response time? So how long does it take? Was it fast enough, like end user expected it? This is also a little bit what is in the DNA of most vendors out there. So to understand, to look at it from a performance perspective. And here also the request is per design telling the response time. So when I do a request, I call an endpoint, how long does it take that I got the response back? And this helps then to understand, why are my users complaining that something took too long or longer than they expected? And when I can filter for the slow request, I can then look into all the details, technical details that happened there. So I can then understand, this was in a specific data center where some issues have been there, or this was executed on a specific infrastructure component where the CPU went high, or things like that. So to really have the full picture, and that the trace can give you that, is then to find out what happened in the backend and find the jump points over to other related signals like metrics. This was happening on a specific Kubernetes pod that was throttled down because it runs out of CPU cycles there and was limited down there.
Mm-hmm. And I think this brings me to another topic which we also discussed, I think, in the video. As we're ingesting traces, there's also the importance of enriching the data that we have with additional information. So, for instance, you just brought up, would the response time, the increase of response time, be correlated with a CPU spike or with something in the Kubernetes cluster, because the Kubernetes cluster, runs into any type of CPU scheduling issues? In order to make that analysis, we need to have the right context, so we know this trace comes from a service that runs in a pod that runs on this particular Kubernetes namespace in that node. Can you tell me a little bit, and I'm not sure who wants to take this, can you tell me a little bit where the data enrichment and the context enrichment typically happens? And I would like to, if you can do me the favor, explain how the one agent does it, and for those people that don't have the one agent, that are doing it on OpenTelemetry, if there's also ways to enrich this on the OpenTelemetry side. And I don't know who wants to, Christoph maybe,
let me take that. So it is critically important for spans, but also all other signals like logs and metrics, to have the proper context on them, especially information about the vertical stack. So where did the signal come from, right? The pod, the container, the process, the host, the cloud information, right? This important vertical stack information must be enriched on every signal. Then you can do the proper slicing, dicing, filtering, or splitting your data through those dimensions. In Dynatrace, even I have to say one cool advantage is, even if you don't have something fully enriched, you can join in the query language we have to the topology over, like a host, and enrich the information about the process or the hardware that it ran on, the processor CPU model, into your data, and also use it for query, for filtering and slicing and dicing. Mm-hmm. But even apart from that, the direct enrichment is very important. One agent pretty much takes care of this automatically. So in Kubernetes, we have our operator that helps it, puts context into the pod. One agent then uses also that information plus the process level information it has, plus the cloud information it gets, does that automatically. In OpenTelemetry, it is actually similar. There is in OpenTelemetry the concept of resource attributes. It's exactly that. It is attributes that go on all signals. And there is so-called resource detectors. And they do pretty much this. There is a process level resource detector, a host level resource detector, a Kubernetes resource detector, a cloud resource detector. They go to the cloud API if it's available locally, fetches the cloud region, the cloud provider, stuff like that, puts it as a resource attribute into the agent or the SDK of OpenTelemetry. And that again makes sure that on the exported protocol, OTLP, those resource attributes are present. And then in a backend, it would materialize as resource attributes or directly enrich attributes, and it's available for filtering.
Cool. And that means
go on, Eddie.
I would assume all these attributes are based on standard convention again. So that means if somebody's following the OpenTelemetry best practices, these enrichments will then on the Dynatrace side or also on any other observability backend that support these conventions show up in the right way.
Absolutely. Yeah, exactly right.
So obviously this enrichment is very, very important, but there's other contexts of enrichment, and I'll explain where I'm going first and then ask if this is something that's supported in OpenTelemetry, right? We have things like feature flags. We have things like blue-green deployments. We have things like AWS tags or release version tags, right? Those are, at least in my experience, usually enriched in the observability backend platform, or that might be part of tagging done in your cloud provider or something, but they're usually associated, not, at least what I understand, on the trace level.
Right.
Obviously knowing which process, which container, which pod, which all those other components, those are things that the trace can pick up. Is OpenTelemetry, do they have slots for additional data, or are there plans for additional data to be able to be put into OpenTelemetry so that if people in their release naming, in their environment variables or anything else start enriching the context at the process level, is this additional stuff that OpenTelemetry can pick and then pass on to the backend, or do you need a third-party backend like Dynatrace to take that data from, okay, we know it's running on this pod also has additional data that we're grabbing from here, and we can put it all together?
So our understanding of this is that in Kubernetes, for example, you have Kubernetes labels. They are very useful context, but they are also a lot, and not all of them are always 100% useful, right? So you can enrich them, but selectively, or you should selectively enrich them. In OpenTelemetry, to my knowledge, this would be possible through an environment variable that OpenTelemetry offers, the OTel resource attributes environment variable. And if you, in your deployment, make sure that your Kubernetes labels are translated into a list in that environment variable, you effectively end up enriching your OTel data with those labels that you want to.
Great.
In one agent, it's working similarly. You have a configuration that you can specify which labels should go on all your data. So you can do it remotely, centrally, and basically enrich your data as well.
Right, but then the benefit of, and I'm not trying to sell Dynatrace here, right? Because I'm sure all of the vendors like us have similar capabilities, right? Where if you have data from outside of that area, right? Again, if you're then pulling in your AWS tags or something like that, because you already have the association with which pod or node or whatever it's running on, that backend can then take that information and say, okay, this belongs with this. So now when we look at the trace, we can bring it back and join it to the other pieces. So yeah, no, it's really cool stuff. And like, I didn't even know OTel can bring in all that other context. That's how much I stay on top of it as a pre-sales engineer.
I can do a quick pitch to some of the content that Henrik Rexed is creating through Is It Observable, his YouTube channel. He's been covering this as well. And also now Adriana, who is on our team, she's also been creating great content on OTel. Switching from how we instrument and how we enrich data, one topic that I briefly want to cover, because it just comes up in more and more conversations, is, and I bring you the statement that I hear at conferences. Dynatrace, Datadog, New Relic, we're also expensive with OpenTelemetry. On the one side, we say we love it, but on the other side, we're super expensive. And these organizations, the ones that I just mentioned, we rather want people to use our agent. And so, why is that? And what I've learned in my conversations is that at least in many cases, it seems that there's a educational gap on what an agent does from one of us vendors in terms of sampling versus what the default configuration with OpenTelemetry does in terms of sampling. Meaning, what I've seen in the recent conversation, the same instrumentation from OTel versus our agent produces 100 times more data. And 100 times more data, storing it in the backend, needs to be more expensive now. But nobody looks into this, and then the first thing to blame is you're so expensive. So my question now to you: is this what I'm seeing here a real thing, or am I just in my little bubble and I was just unfortunate to have some conversations, or is this also something that you see?
Yeah, so I think one point that we definitely see is the amount of data volume, and that's what you mentioned already, what is a little bit in the DNA already. When you do distributed tracing on large-scale customers, you also need to think about how to handle this load, and also which of the data is relevant and is needed here, because not every data point, when I have a specific endpoint on my blog post and it's opened 1,000 times a minute or something like this, and everything went well and fast, I typically don't need all of this information inside of it. I want to have a good portion of it. Okay, the response time was fine. I didn't saw any failures here, or I have a good probability of how to collect this data and how to find out which data is relevant. This a big chunk of knowledge and architectural work, like from Christoph and all his colleagues, went into this to do this in a smart way automatically, also to assure to have then end-to-end traces. So there need to be some information how can be assured when something is coming in, that also we have then the database calls in the end when several microservices got hopped on here in a good probabilistic way to find out to have all the relevant data there. Mm-hmm. And I know there are mechanisms in OpenTelemetry also to do sampling to reduce this data, because they face the same problems. I know even that colleagues from us contribute there to bring this forward, so to have similar algorithms to reduce the data, or to just have the relevant data or more relevant data there that is processed here. But OpenTelemetry is, as far as I know, not as far as most of the vendors here, where put a lot of knowledge there. I think Christoph can jump in here with more details about how this works.
I mean, OpenTelemetry does a good job. It's a very a modular system to put samplers in place that have different sampling strategies, from simple probabilistic to more advanced ones. In one agent for Dynatrace now data collection, we've over the years refined our strategy on how to sample data right for tracing, and we apply basically I can describe two major strategies. The one is we do different sampling rates based on the endpoint that's being hit. Those that are being hit a lot get a lower sampling rate than those that are being hit rarely. Like the resource requests against your images on your website would have a very low sampling rate. That means not every transaction is being captured. Mm-hmm. But the login request that only happens once or far fewer times, right, would get maybe 100% sampling rate. It is dynamic though, but rarer endpoints get a better sampling rate than frequently used endpoints. That's one way to overall, manage your observability cost well. And the other one is overall, we look at the whole system. And if you get into peak usage, we then, we start rate limiting at some point in the system to control the cost. So if you blow your monitoring system on Black Friday because you have 10 times the traffic, we will start reducing the overall sampling rate to manage basically the cost in your system.
Mm-hmm. To recap, because I think this is hugely important. You said the first approach, right? We want to make sure that those in correlation less frequent transactions, we capture them, because if a login that may happens 100 times an hour versus your image request for your website happens 100,000 times, you want to have those 100 login requests because they are business critical, they're important.
Exactly.
And I think so. That's one thing. I also looking into some of the observed systems that I've seen. What I've done and stuff based on stuff that I learned from you, Christoph and Thomas, I opened up the Distributed Traces app and I used the grouping feature to figure out what is the number of traces that are coming in per endpoint. And you can immediately see on the very top, where there's no sampling involved, it's all these JPEG requests, those CSS, all these static resource requests that are coming in. And then I wonder, why do we 95% or sometimes 99% of requests that are captured are these static requests? And this is why people then say, well, you're super expensive. But the stuff that you are capturing is actually meaningless anyway. And I think, and that's something, that's why I like it that we get here, that we're discussing this. And this is all possible, as you said, with OpenTelemetry, but you need to put the effort in to configure the system so that it works for you, versus you can also go with a vendor agent and these things are being taken care of for you.
Yeah, and I think the other thing that's important to point out too is we're talking about sampling the traces, right? So you're not going to have that span level data for every single trace coming through. However, that doesn't mean we're sampling the metrics, right? So it's not going to be like if you only capture 1 out of 50 image requests that you're going to see, like how we only had 20 image requests in the last minute. No, all that information, all the metric level information is still there. And I'm assuming that with OTel on its metric ingestion is doing the same thing. You'll still have the full picture from that metric point of view. We're just talking about that detailed level trace. And Thomas, you said something very important about statistical probabilities, right, earlier, where if something is happening that frequently, and this goes back to even with the CPU sample when we first started introducing it, it's like if a method is happening so fast or a trace is happening so often, and it's going to show up in there, right? Just not every single one. But if it's a problem and it's running slowly, it's going to be there because it's going to be running longer. It's going to be a bigger part of the picture. So, no, and everyone's doing sampling these days because, again, this data load. And I think the big challenge for people, especially people coming from the earlier days when it was easier to capture everything because systems were much simpler, of letting go of having at or near 100% of everything and trusting in, okay, we got to look at statistics, we got to look at probability of what we capture. We still have that full context though from the metrics, so we'll still know if our failure rate is high or anything else. And just that key idea of if a problem happens on one trace and one trace only, is it a problem or is there a blip, right? Are you going to get everybody up and say we have this problem because one trace took 10 seconds? maybe there was a power surge, right? So it's just that context. And I know it makes people uneasy, but I think, what I loved, and again, not to do a commercial for Dynatrace here, but when we came up with that, that smart sampling, I forget the name we had for it, but the smart sampling idea where we're going to do it based on volume and all that kind of stuff. I was like, okay, this makes a hell of a lot more sense than just random sampling, right?
Yeah, no, the adaptive traffic management, because in the end, it's about the data volume that on the one hand side need to be stored somewhere. So you need to have it somewhere on disk. And that's, I think this issue also you have it when you store it on your own premise to have the hardware available. But when you have it stored, it's not just the storing of this data. You also need to have a lot of CPU power to analyze this data. So if you have all your traces, then you have the next problem. You have perhaps some rarely occurring issues that you need then to analyze, and then you need to run needle in the haystack search to really find the erroneous or the slow request here in this huge haystack there. And this then in the end is typically also using a lot of CPU power here. So that's what you then have when you have this by yourself.
But you bring up a very interesting topic. Maybe let's dive there a little bit, which is metrics or spans. Now, let's get into this a little bit. What's now better? Now, if you produce a metric on non-sampled data, like in the source, of course, that's more accurate if you look at counts and such. Spans are sampled, usually, so you don't have, exact counts then, but you have all the context. This is a huge difference. In metrics, of course, you can also put the horizontal, the vertical stack, that doesn't increase your cardinality, but you cannot put everything on a metric. You can't put the full exception message or the stack trace or all HTTP headers that appeared on your metrics, because you run into cardinality explosion. Your metric, if you put a random ID as a dimension on a metric, then it becomes an event, right?
Username or something like this, if you can the idea.
Right. The efficiency of a metric comes from the fact that if you have a series, it's just a number of integers or doubles, in a row. That's very efficient to query. If that array is not there anymore because it's just one number per cardinality, combination, then it's like an event. It's not efficient. It's not as efficient anymore. Now, that is why in most metric systems in the world, or all of them, you cannot do high cardinality. You have to choose your dimensions that you want to split by. But what if you have a problem and you want to split by something you didn't know before you want to split by? You want to filter, the username, now it's obvious, but what about the order ID or the
even just the product
or something
ID.
else?
Yeah.
The product ID, something that's high cardinality, and in combination it would explode. But so you can't put it on a metric. Now on a span or a structured log, for that matter, is similar or same. You can put all the dimensions, stored as it is, and then you can do those kinds of queries, and also needle haystack. And Thomas, I have to say, needle haystack, we became extremely efficient nowadays in needle haystack queries, also in Dynatrace, now with Grail, which was built for indexless raw data search for logs, but we use the same thing for spans. So searching for individual haystack, IDs or whatever is very efficient. And it can also very efficiently extract time series on the fly from spans. So you can do a make time series out of spans. Looks like an actual metric, but it is on the fly calculated. And I can split it by order ID. I can split it by request ID. If I need to, the system can handle it quite efficiently, not exactly as efficiently as it was a metric in the first place. But still, Grail became very powerful. So Dynatrace, the query system, storage and query system, became very powerful in doing so. And this is also where some industry vendors go to, which is the unknown, scenario where you didn't know upfront you need something. Now you need it. You weren't able to put it on a metric, but now you want to analyze against this in your raw data. this is a very exciting new direction that the industry is going to.
Mm-hmm. And I think, Christoph, you also did a great job in the video, folks. You can check it out as well in the link, in the links in the description here, where you walk through some of these scenarios and showed exactly that use case. But I want to, just to clarify, this will obviously work and be accurate depending on how much data you really ingest and where you sample. And this is why sampling is so important,
Yes.
like sampling the right things. And this is why, ignore or sample things away that are not business critical and focus on those things that are critical. And then you can also make these things a reality, what you just said. Yeah.
Thank you for tying back that knot to sampling. We came from there because when you do the on-demand time series creation, you need to be aware of the sampling that has happened originally on your spans and work with that, extrapolate, etc.
Yeah. Cool. I think we're getting it to the end. It's amazing how time flies. Almost an hour.
I thought we were only about a half hour in.
But I want to give each of you still a chance to say anything that we may have missed, because there's a lot of people out there that are new to traces. I don't know anything. And Thomas, I want to start with you. Anything else that we missed that you want to highlight?
Oh, I'm very sure we missed something. But what I think is what Christoph brought up here is using this data to analyze on and on. So when you have metrics, you typically need to decide beforehand what do you would want to look at. Like, typically something failed, okay, or you have perhaps performance information, so that is typically important. You want to have this, but all this other information on it, and to make this really searchable, just to access this data. This is really helpful, especially in today's days where the data volumes become huge. To find that and to be able to analyze this data on the fly in real time, this is really key here to do the right decisions and to find things that you have not been aware of beforehand. So I think that's an important point that we should highlight. Yeah.
Mm-hmm. Christoph.
Yeah, I was thinking about the summary or overall statement about distributed tracing. I think we need to differentiate two things: the data collection and the analytics capabilities. So data collection nowadays became much more of a commodity through OpenTelemetry. So whether you choose a vendor agent or OpenTelemetry, well, it's a matter of each gives you some advantages, disadvantages, or convenience functions or additional features. That's fine. So either is okay. What's important, much more important, is the analytics backend you go to. And this needs to give you two things. It needs to give you out-of-the-box answers and anomaly detection, I would say. So out of the box with your trace data, it should do something useful that doesn't involve your daily interaction. It should alert you out of the box about issues. And the second thing is, if you need to dig into the data, it should give you a powerful way to do so. Analyze, slice and dice your raw data as you need, as you see fit for a certain troubleshooting case. I think that's the two big things you should look for in an observability backend.
Thank you. Brian, how about you?
Well, first I want to pour a little out for the old term pure path. That was our old word for what traces are now. Now I got water all over me. But yes, rest in peace, pure path. But I think, first of all, Thomas and Christoph, all the work that you all and everyone you're working with on maintaining the ability and refining the capabilities around collecting traces and all this has just been fantastic over the years. And I also just want to shout out, all the companies that you mentioned earlier, Christoph, who started getting into this whole idea of how do we standardize this, right? I think it's a great testament, once again, to the IT community of sharing and letting everybody get better, because not that it's full-on proprietary, but you can take a look from a vendor point of view. If we're going to create a way for people to not necessarily have to use the agent that we're selling by agreeing on these terms. And just the fact that it came together and everyone recognized the need for this, obviously not only creates something like OpenTelemetry, but creates better practices for the vendors to leverage themselves. So I just always am in awe of when things like this happen, because it's, when big money's involved, people don't really do too much to help each other out. So thanks for everyone who is doing that too. And I hope people, this has just been a fascinating conversation, and I'm sure we can go on for another 3 hours, but we'll have to have an internal one about the history of Dynatrace and all the fun things we used to see. Memory lane. Anyhow, Andy, back to you then.
No, just want to wrap it up. Say thank you, and folks, make sure to check out all the links. Besides the video from Christoph, there's another series of videos that we haven't talked about today. It's Open Pipeline, because there's another component. As data gets ingested, in our case, into Dynatrace, we can extract data, we can decide what to do, how we enrich it, and also what we store. And we'll just make sure that we link all of these assets in the description. But yeah, looking forward to where distributed traces, OpenTelemetry will bring us in the years to come. Thank you.
Thank you all.
Thank
Bye-bye.
you. Bye.
Thank you. Bye.
Bye.